Reaction yields. The relative amounts of reactants and products represented in a balanced chemical equation are often referred to as stoichiometric amounts. So that means that when we have exactly balanced amounts of reactants so that they react and there's nothing left over, then we call that a stoichiometric amount. Generally, when we've been looking at questions before this section, those are the kinds of questions that we're looking at. We assume that there's, if I require 2 moles of one substance and 3 moles of the other, that I have those amounts specifically, or I have a ratio of that so that they're going to be used up. But that's not always the case, and sometimes there is a reactant that is present in excess and a reactant that is limiting. So, for example, let's go back to our cooking analogy here. When I'm making grilled cheese sandwiches and I have 2 slices of bread and 1 slice of cheese to make a sandwich, and if I have 28 slices of bread and 11 slices of cheese, how many sandwiches am I going to be able to make? Well, if this is our chemical equation, one sandwich is 2 pieces of bread and 1 piece of cheese, and I have 28 pieces of bread and 11 pieces of cheese, then that means that I can make 11 sandwiches, right? Because each sandwich takes a piece of cheese, and I have 11 pieces of cheese. So if I make 11 sandwiches, how much bread is that going to require? Well, it's a 1-to-2 ratio, so that's going to require 22 pieces of bread, and I have 28 pieces of bread. So that means that I have 6 pieces of bread left over after I make 11 sandwiches. So that means that my cheese was the limiting reactant and my bread was the excess reactant because I had some left over. So when that situation occurs in a chemical reaction and the reactants are not present in an exactly balanced amount, the same ratio given by their chemical equation, then we always have what's called a limiting reactant, which is the one that runs out first, and an excess reactant, which is the one that is left over after the reaction is finished. So here, this is called the Physics Education Technology website. So sometimes I have links to these simulations on Sapling. If you scroll down a little bit, and instead of just clicking on the upcoming assignments at the top of the page on Sapling, if you scroll down and look at each section, there's links to some of these simulations down there. And this is just an example of one of them. So we can do different recipes here, different chemical equations. So here's the cheese sandwich that we were just working with, or we can have a different one with a piece of meat and cheese and bread, and we put some number of pieces of bread and some number of pieces of meat and some number of pieces of cheese. See, and then we have 4 sandwiches. We can make 4 sandwiches because I have 8 pieces of bread. And if each sandwich takes 1 piece of meat and I made 4 sandwiches, then that means I have 2 pieces of meat left over and I have 1 piece of cheese left over, and I can't do anything with that meat and cheese because I ran out of bread. So bread is my limiting reactant, and in this case I have 2 excess reactants. The meat and the cheese are both excess reactants. So the same exact thing occurs when we're talking about chemical reactions, right? So here's the bread, and here's the cheese, and here's the sandwich. So we put in some bread, and we put in some cheese, and I can make some sandwiches. Here are the sandwiches. And then I have some leftover bread, and I have some leftover cheese. So in this case, this is a good situation to illustrate what happens when I have both of them left over. So which one is limiting in this case if I have both substances are left over? Well, let's look at the recipe here. It takes two hydrogen molecules, two H2s, and one O2 to make water. So here's water, and I've got to do this two at a time. So I always need two molecules of H2 to react with one O2. So I've got plenty of O2 left. I have two molecules of O2 left, but I only have one molecule of H2 left, and my recipe says I need two. So this is like the bread, right? H2 is the bread. I only have one slice of bread left. I can't do this recipe, so I have two leftover pieces of cheese. So bread is my limiting reactant, hydrogen is the limiting reactant, and oxygen is the excess reactant. So here's another example. One H2 molecule plus one Cl2 molecule makes two HCl's. So make sure that it's balanced, so we have a balanced equation. So now imagine combining 3 moles of H2 and 2 moles of Cl2. So let's do that. We've got 3 moles of H2 and 2 moles of Cl2. Three moles of H2. So we put our conversion factor, moles of H2 on the bottom, and if we're trying to figure out our limiting reactant, then let's figure out how many sandwiches we can make. In this case, the sandwiches are HCl, right? That's our product, HCl. So according to my recipe, it takes 1 mole of H2 for every 2 moles of HCl, right? The numbers in front here, 1, 1, and 2. Okay, and we have 2 moles of Cl2. So if I have mole of Cl2 on top, I have to put mole of Cl2 on bottom so they cancel. And I want to figure out how many sandwiches I can make. So the same thing, moles of HCl. So according to my recipe, it's 1 mole of Cl2 for every 2 moles of HCl. Make sure your units cancel. Okay, 3 times 2 is 6 moles of HCl. And 2 times 2 is 4 moles of HCl. So with Cl2, I can make 4 moles of HCl with that amount of Cl2. And with H2, I can make 6 moles of HCl. So how much HCl can I make? 4 moles. If I have enough bread to make 4 sandwiches, and I have enough cheese to make 6 sandwiches, how many sandwiches can I make? 4. I can only make 4 sandwiches because then I run out of bread, right? I have enough cheese for 6, but I've already run out of bread. So I can make 4 moles. This is my theoretical yield. So the total amount of product that I can make is called the theoretical yield. And so what we see here is that if I have 3 moles of H2 and 2 moles of Cl2, then I can only make 4 moles of HCl. And when that happens, I'll have 1 mole of H2 left over. So if I'm making 4 moles of HCl, and there's 2 moles of HCl per 1 mole of H2, then how much H2 is it going to take to make 4 moles of HCl? Well, 4 divided by 2 is 2. 2 moles of H2. So I can only make 4 sandwiches because that's what my limiting, I run out of Cl2. This is my limiting reactant. When I make 4 moles of HCl, how much H2 does that take? That takes 2 moles of H2, according to my recipe. Well, I have 3 moles of H2, and it only takes 2. So that means I have 1 mole of H2 in excess. And that means that Cl2 is my limiting reactant. And H2 is my excess reactant. So here's a visual representation of that reaction. I have 6 H2, these ones, and I have 4 Cl2 molecules. So before the reaction, I have H2 and Cl2. But after the reaction, the Cl and the H have been stuck together, so now I have HCl. So all of the Cl2s have been broken apart and they've all connected with H atoms. And after all the Cl2s are broken and they're all full and I've run out of Cl2 atoms, I still have these H2s left over. So the total amount of product that you can produce in a reaction before you run out of something is called the theoretical yield. But sometimes, in fact usually when you perform a reaction, the amount of product that you get is actually less than the theoretical yield. There are a number of reasons for this. Sometimes the reaction equilibrium doesn't have a very large equilibrium constant, which means that even when the reaction is complete, it's come to equilibrium, there may not be 100% products. So the reaction dynamics themselves might limit the amount of product that you get. And sometimes it's just for more practical reasons, like after you perform a reaction, the material that you're trying to isolate is stuck on the inside of a flask, and you have to use a spatula or a metal spoon or something to scrape it out. And sometimes when you're trying to transfer it from one place to another and dump it on your weigh paper and bring it to the balance, sometimes material is lost. Some is left behind in the flask, some gets left behind on the weigh paper. So the actual yield, the amount that you're actually able to isolate at the end of an experiment, is less than the theoretical yield. And so generally it's useful for us to calculate what's called the percent yield. And the percent yield is just the ratio of the actual yield to the theoretical yield. So a reaction has a theoretical yield so the percent yield equals the actual yield, what we were actually able to isolate after the reaction was done and maybe we dropped some or something, over the theoretical yield. Times 100. So our actual yield is 4.79 grams. Our theoretical yield is 5.68 grams. %. So, although in this reaction it was possible to get 5.68 grams of product, according to how much reactant I started with, I was only able to isolate 4.79 grams. So 4.79 divided by 5.68 is 84.3%.